A police officer finds 80 meters of skid marks on the horizontal road surface at the scene of a car crash. The kinetic friction coefficient between the tires and the road surface is 0.8. What was the velocity of the car when it started skidding? Neglect air resistance. So we can start by looking at the kinematic equations and figuring out which one we can use to figure out the initial velocity of the car. And note that time is not given. So I'm just going to quickly write down the 4 kinematic equations. And the last one is the final velocity squared equals the initial velocity squared plus 2a times the displacement. So these are our 4 main kinematic equations that we can use to describe motion. So in this problem, we're given the displacement, and we can probably calculate the acceleration because the kinetic friction coefficient is given to us. So the only one that's missing, and the one that we cannot solve for, is time. So all 3 of these first equations have time as part of their equation, so we're not going to use any of these. Instead, we're going to use the last one. And we are solving for the initial velocity of the car when it started skidding. So we can use this equation. So we can simplify it a bit. We can move these to the same side. And we need to solve for the initial velocity. Well, we know that the final velocity is 0 since the car kind of crashed and there are only 80 meters of skid marks. If the car still has some velocity, the skid marks would continue. So after the crash, the car would have no final velocity. So you're left with the negative of the initial velocity squared. It's 2 times acceleration, just change in x. So the initial velocity is given by the square root of minus 2 times the acceleration times the displacement. So now that we have that, we need to actually calculate the acceleration. So if this is the car and it's skidding, the only force acting on it while it's skidding is going to be, let me draw an arrow, it's going to be the force of kinetic friction, and that will oppose the direction of motion. So the only force acting on it is the force of kinetic friction. And since it's acting opposite, the force of kinetic friction is negative, since it opposes the motion of the car. So if up is positive, the direction of the car's motion is positive, then the force of friction is negative. It's acting in the opposite direction. So the negative of the frictional force is equal to the mass times acceleration. This comes from Newton's second law, which says that the summation of all of the forces, or the net force, is equal to the object's mass times its acceleration. But in this case, the frictional force is the only force acting on the car, and is in the opposite direction. And that is how we got this equation here. We also know that the force of kinetic friction is given by the coefficient of kinetic friction times the normal force, where the normal force is equal to the car's weight, mg. So we can substitute that in for the normal force. So the force of kinetic friction is equal to the coefficient of kinetic friction times mg. And that's the force of kinetic friction. Now we can use this to solve for the acceleration, a. So know that the force of kinetic friction is equal to the coefficient of kinetic friction times the car's weight. So we can plug that back in to our equation, because we don't need parentheses. And that is equal to the car's mass times acceleration. If you notice, the mass cancels out. So we're left with the acceleration is equal to the negative of the coefficient of kinetic friction times g, or the gravitational acceleration. So I'm going to make more space over here. I'm also going to write down the formula we calculated for the initial velocity earlier. And I'm going to erase everything else over here. So from earlier, we know that the initial velocity is the negative of 2 times the acceleration times the displacement, and the square root of that. So now we just need to plug everything in. It's the square root of 2 times the acceleration, coefficient of kinetic friction, times g, times the displacement. And that's our final formula for the initial velocity of the car. And the negative is no longer there because it cancels out. So this would solve the problem of having a negative square root. So now we just need to plug everything in and solve for the initial velocity. So square root of 2 times coefficient of kinetic friction of 0.8 times 9.8 times the 80 meters of skid marks. So now, if you simplify all of this, you should get that the initial velocity of the car, or the velocity when the car started skidding, is going to be about 35 meters per second. And that is how you would solve this problem here.